Hi Trigoners, so we're going to do a video right now. We're going to do some notes on types and properties of numbers. So we already watched our video from Professor Dave. He helped us out a little bit talking about types of numbers. So go ahead and look at the awesome diagram there. We are going to just talk about each type of number. Notice that we have natural numbers, integers, rational numbers, irrational numbers, real numbers, etc. Now notice the difference between whole numbers and natural numbers. So natural numbers, for example, might be 1, 2, 3, 4, etc., where whole numbers include 0. And that's why if you look at the diagram, you could say that natural numbers are a subset of whole numbers. Okay, so let's go ahead and answer some questions now that we've talked about the different types of numbers. Or actually it might help too, I know you watched the video, but if you had irrational numbers, that would be like the square root of 2, e, and pi, square root of 7. Those are irrational numbers. And notice they're real, but over here we would not say that a rational number is an irrational number at all. All right, so go ahead and try the true or false questions. Pause the video and use the diagram to help. Okay, let's see how you did. So in other words, a natural number is always a rational number. Well, sure, looking at the diagram, and again, natural numbers 1, 2, 3, 4. Rational numbers can be written as a fraction. A rational number is always a natural number. Not necessarily, because a rational number, for example, 1/3 is rational, but it is not natural. Let's see, rational numbers are a subset of integers. Also not true, because again, a rational number is 1/3, and an integer would be something like 1 or 2 or 3 or negative 1, etc. And so notice that integers are rational, but rational numbers are not all integers. Let's see, natural numbers are a subset of integers. That is true, because all natural numbers are integers. And the last question, the integers are a subset of irrationals. Not true at all, because again, if you look at the diagram up here, we have irrational numbers that are like radical 2, radical 7, e, and pi, things like that, where integers are 1, 2, 3, negative 17, etc. So integers are not irrationals at all. Okay, let's take a look at the properties. So go ahead and look at the table there. Okay, you might want to pause the video and look at each example and each type of property, but I'll just highlight a few things. Distribute, you're actually distributing a number over parentheses. Commutative, you're changing the order. Notice this was a 3 and a 4 and a 4 and a 3. Notice associative, you're associating things, you're grouping things, and notice that the order didn't change. We have 3, 4, 5, but you're associating the 4 and the 5, and over here you're again associating or grouping the 3 and the 4. Now, additive identity, you start with a number and you get that same identity back. So you do something to it and you get the same identity. Multiplicative identity, same thing. You start with a number and get that same number back. Where inverses, I would think of more like opposites, because you add the opposites and look, you get the additive identity. Or multiplicative, you multiply opposites and you get the multiplicative identity. Okay, so go ahead and pause the video and use the table to fill in the property for each of 14 through 22. Okay, so let's go ahead and check on these properties here. Notice that we have associative, because you changed the grouping symbols. We also have commutative, because you changed the order. Over here for number 16, multiplicative inverse, because this is 3 times 1/3. They're opposites, and you ended up with 1, which is the multiplicative identity. For number 17, this one was kind of tricky. Notice that the 5, the 5x, the 3y, and the y are in the same order, but you changed the grouping symbols. That's associative. Number 18, these are opposites, so you ended up with additive inverse. Again, number 20, you started with something, did something to it, and got the same thing back. That's the identity. Distributive, you distributed the x and the y. And for additive identity, you added the identity. You added 0 and ended up with the same number back. Okay, nice job, everybody.